Josh, what's up?
Nothing, Dom. I'm just studying business statistics.
Would you maybe want a snack? Like some chips and salsa?
Yeah,
Well, I already have the chips.
but I don't have any salsa.
I have an idea.
Since we have a stats project coming up that's due, and we all want salsa, why don't we see what kind of tomato gives us the most?
Wait!
Aubrey, when did you get here? I've been here the whole time. When did you show up?
We will first do an Anova experiment to test the weights of tomatoes.
Aubrey and I think that organic are the best and the biggest, and obviously girls are always right.
Well, I think naturally grown tomatoes are going to be the best.
You guys are all wrong. Hydroponically grown tomatoes are going to win it.
What's a tomato?
What did you just say?
Tomato.
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 Say potato.
Potato.
Say tomato.
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 Let's go buy some tomatoes.
Yeah!
Let's go buy some tomatoes.
Welcome to the remix. D1 Insuperable. Let's go. La mano arriba. Come on. Cintura sola.
I think these are the best, and they'll make the best salsa. Mine's cheaper. Not that that has anything to do with it.
But mine are hydroponic.
Mine is the original, and you can never go wrong with the
I think the organic are the best ones, don't you? Totally better than the other ones. I think these are just gonna give us so much more salsa. Yeah.
Que todo empieza. Mueve la cabeza. Danza kuduro. Bailando me robó la atención desde el momento en que la vi. Una nena latina. Let's get down to business.
To find n, we're going to use the count function. For x bar, we're going to use the average function. For variance, we're going to use the var s function. For double x bar, we're going to add each of the x bars together. And then divide by 3. For the standard deviation, we're going to use the square root function for each variance. For the degrees of treatment, we're going to use k minus 1, which k is how many groups we have. So we have 3 groups, so we're going to do 3 minus 1 to give us 2. For our degrees of freedom of error, we're going to use n minus k, so we're going to do 30 minus 3 to give us 27. And our total, we're just going to add the 2 together to give us 29. For the sum squared of the treatment, take n for organically grown times x bar minus our double x bar raised to the power of 2. Then add our n for naturally grown times n for naturally grown by x bar minus our double x bar raised to the power of 2. Next, add our n for hydroponically grown by x bar minus our double x bar raised to the power of 2. And our answer is 39.466. Next we are going to do the sum square of the errors, where you take n minus 1, which is 9, times the variance of organic, plus 9 times the variance of natural, plus 9 times the variance of hydroponic, to give us a total of 46. The total for everything is 85.467, which is the sum square of the treatment plus sum square of the error. To get the mean square of the treatment, take the sum square of the treatment divided by the degrees of freedom for the treatment to get 19.733. For the mean square of the error, take the sum square of the error divided by the degrees of freedom of the error to give us 1.704. For our test statistic, take mean square of treatment and divide it by the mean square of error to get a test statistic of 11.58261. For our critical value, we are going to use the fn function with a probability of 0.95 because our alpha is 0.05. Our degrees of freedom 1 is the degrees of freedom of the treatment, which is 2, and our degrees of freedom 2 is the degrees of freedom of the errors, which is 27, to give us a critical value of 3.35. For the p-value, we will use the t-dist function and use the critical value of 3.35 as our x, our degrees of freedom, which is 27, and a 2 because it's a two-tailed test to give us a p-value of 0.0023718.
Running the Anova test using the HO that all means are equal and then the HA that one mean differs.
We found out that the p-value is 0.0023 and we used the alpha level of 0.05.
With a p-value that low, we must reject HO and assume that HA is correct. At least one mean differs. Therefore, we must run a Bonferroni interval test.
For our standard deviation for 1, which was organic, from the Anova test, we found it was 1.398. For 2, which was natural, we found it to be 1.5055. And for our third, which was hydroponic, we found it to be 0.9428. And our sample size is 10 for each, and there are 3 possible combinations that exist because there are 3 different groups. First, we are going to test the pair of organic versus natural, which is 1 and 2. We use an alpha level of 0.05. Our mean for group 1, organic, was 9.2, and our mean for group 2, which was natural, was 10.4, to give us a confidence interval with a lower boundary of negative 2.86 and an upper boundary of 0.46. Next, we are going to test the pair of organic versus hydroponic, which is 1 and 3. We use an alpha level of 0.05. Our mean for group 1, organic, was 9.2, and our mean for group 3, which was hydroponic, was 12, to give us a confidence interval with a lower boundary of negative 4.46 and an upper boundary of negative 1.14. Lastly, we are going to test the pair of natural versus hydroponic, which is 2 and 3. We use an alpha level of 0.05. Our mean for group 2, natural, was 10.4, and our mean for group 3, which was hydroponic, was 12, to give us a confidence interval with a lower boundary of negative 3.26 and an upper boundary of 0.06.
So now that it comes to making salsa, if you're going to use organic and natural, since the means are statistically equal, it doesn't matter which one you choose.
It's the same case for natural and hydroponic. The means are statistically equal, so it doesn't matter which one you use.
See, that's weird, because for organically versus hydroponic, there is a statistical difference, and therefore you're better off going with hydroponic tomatoes because the mean is statistically higher than your organically grown tomatoes.
After cutting up the tomatoes and adding a few different herbs and spices into the bowl, you should mash it pretty well. And there we go.
All right.
Our delicious salsa.
All right.
Let's try
I
it.
think it's time to try.
Yeah, let's dive in here.
Whoa, 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 whoa. We forgot one of the most important ingredients. So onions.
And now that we added the onions, we have finished our salsa. There we go. Alright guys, I think it's time to eat this.
Let's
It's time
try
to
it.
try this salsa, huh?
That's some prime salsa right
All we
there.
needed was onions.
All we needed onions and tomatoes and bang.